bonus section here is I'm going to go over the quiz from drawing Lewis structures of compounds, and just walk you through these so that you can get a good clarification on how to do these if you see these on the test. Alright, so this first one, remember I had a little typo here, so it's PO with the subscript 4 and then a little 3 minus, and this just means that this compound has a -3 charge, which just means that it has 3 more electrons than you would expect it to have. Alright, so what you need to do when you're setting up one of these Lewis structures is you need to look at each element and determine how many valence electrons it's bringing into the compound itself. And then understand that just because phosphorus is bringing in 5 electrons doesn't mean that it wants 5 electrons. It wants to fulfill the octet rule. That's why it's combining with oxygen. So in order for it to fulfill the octet rule, it has to have 8 valence electrons available to it. Oxygen is bringing in 6 electrons each. In this case, there's 4 of them. So we'd count 24 there. 6 times 4 is 24. Phosphorus, there's 1 phosphorus atom, and it's bringing in 5 valence electrons. And then it has a -3 charge. So we're going to add 3 more electrons to it. So our allowance, or how many electrons we have to use when we set up our structure, is 5 plus 24 plus 3, which is 32 electrons. Alright, now when we're setting this up, there's a couple common rules. Oxygen is very rarely a central atom. Carbon is always a central atom if it's there, and hydrogen is never a central atom either. So oxygen and hydrogen are never central atoms, carbon always is. In this case we have phosphorus with oxygen, so we're going to start with phosphorus because oxygen is never a central atom. Now, a good way to do this, and this is not necessarily the correct way when you go to chemistry, but for this class I want you to be able to at least set these up so that you can get everything to fulfill the octet rule. And so if we go ahead and fill this out, what we notice is that phosphorus is our central atom and I have oxygen all around. And I don't know that this is correct, but the first thing I want to do is I want to get everything to fulfill the octet rule. So you go ahead and draw in your valence electrons and make all of these atoms stable, make all of them happy, make all of them fulfill the octet rule. And then after you get them all filled in, then you're going to count them up. Alright, so let's go ahead and count them up. We have 1, 2, 3, 4, 5, 6, and then the line is 2, so that's 7 and 8. And then we have 8 here, that's 8 plus 8, that's 16. We have 8 here, that's 24, and we have 8 here, that's 32 electrons. And that's the answer for your first one. Okay, and this whole thing, sometimes you'll see it bracketed in, and then then you'll have a little negative, a 3 minus sign after it. You'll see it that way sometimes. You don't need to do that. I'm okay. Alright, so here we got chlorine, and we have 3 oxygen atoms, and then we have a negative charge. Okay, so if we count chlorine, chlorine has 7 valence electrons, and because it's in group 7 of the periodic table. Oxygen has 6 each, and there's 3 of them, so that's 18 electrons. And then a -1 charge tells us to add 1 more electron. We add these up, we get 26 electrons. Now we go ahead and make this. Notice that there's oxygen present. We don't want oxygen to be in the center. We do want chlorine to be in the center, however, so go ahead and attach all of your oxygens. Get all of them to fulfill the octet rule. Notice I'm drawing lines this time. Each line represents 2 electrons. Count them up: 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, and 24. However, I am forgetting 2 electrons here because chlorine only had 6, now it has 8. So now when I count them up, it should equal 26, and we're set with that one, and we're set with that one. Now those are fairly easy because they're all single bonds. Let's take a look at this one, carbon and oxygen. Carbon has 4 valence electrons, oxygen has 6. That's a total of 10 electrons that we're going to have to use. We connect carbon to oxygen, and we get everything to fulfill the octet rule. 2, 4, 6, 8, 10, 12, 14. Uh-oh, 14 does not equal 10. Anytime that you're using more electrons than you have available to you, you need to add a double bond. If we add a double bond, that means that we're going to have to subtract electrons. And remember, we're keeping the octet rule in place. So now we have 2, 4, 6, 8, 10, 12. We still have too many. If you still have too many, you need to add another bond. And now I have a triple bond. Notice that carbon now has 2, 4, 6, 8, 10 electrons available to it, and according to the octet rule, it does not want that, so you have to subtract 2 electrons from each. Now when you count them up, 2, 4, 6, 8, 10, 10 equals 10, we're all set. If you want to double check yourself to make sure you're correct, look at each one of these atoms and just confirm that there are 8 electrons touching it. 1, 2, 3, 4, 5, I'm sorry, 2, 4, 6, 8. Carbon is happy, and again oxygen 2, 4, 6, 8. Oxygen is happy. Both of them are stable. They fulfill the octet rule, and they are all set. And this is the quiz. Actually, let's just do this last one too real quick. Fluorine has 7 valence electrons. There's 2 of them, so you're going to add 14 in. Oxygen has 6 valence electrons. 6 plus 14 equals 20. We're going to have fluorine and fluorine and oxygen, and then we're going to just go ahead and have everything fulfill the octet rule. All these are going to have 8 available to them. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. That's it. Checked out. We're all good. And that's it. So that was the quiz, and that was the quiz that so many struggled on. Hopefully it's a little clearer to you.